Hey everyone, this is the Radical Tutor here explaining. This is Organic Chemistry second year, Organic Chemistry 1. So those that are doing Organic Chemistry, this is your video here. Alright, so today we are going to look at the ozonolysis of alkenes. So what is this ozonolysis of alkenes? So when we are saying that we are ozonolizing, we mean we are adding ozone to an alkene. So you are aware that ozone is O3. So this is ozone and we are trying to add it to an alkene. So we are trying to add ozone, which is O3, to an alkene, and this process is called ozonolysis. Alright, so what is this method all about? So this method is about cleaving alkenes. So if you want to cleave alkene, to cleave meaning that if you want to cut alkene into two parts, so we use what we call as ozone, or the process of ozonolysis, to make sure that we cleave alkenes. So now, the main idea about the video is to carry out the mechanism to see how the process takes place. So that's what we are going to look at. So now, we are going to start by giving the general mechanism. So the general mechanism is that we are going to assume that we have an alkene. So this is an alkene. Let's say this is 1, 2, 3, 4. So this is a butene having a double bond here, which is making it as an alkene. And then after this, we are going to say this reacts with ozone, which is O3. So the question will be carry out the mechanism to see how it proceeds. So apart from you being given the ozone, there could be also some other compounds that will be put in the solution or in the reaction vessel, but we shall look at those later. Now let's carry out the mechanism and see how it proceeds. So we are carrying out the mechanism of ozonolysis. Alright, so what we are going to do is we are going to write the structure of alkene. So the structure of alkene here is, we have the structure of alkene, which is C double bond C, like that. This is butene, just like I've said in the preamble. And then from here, what we are going to do is we are also going to write the structure of ozone. The structure of ozone in this case is this one. So how can we bring it? So the structure of ozone, we are going to write it like this, which is given by O, double bond oxygen, and then single bond oxygen. This oxygen here should have excess of electrons, so negative. This oxygen on the middle has 3 bonds, so no wonder it should have a positive charge. Alright, so whenever you find that oxygen has 3 bonds, please make sure that you put a positive charge on it, because it means it is unstable. Alright, then from there we are going to have also 2 of the lone pairs on this oxygen. So now we are going to carry out the mechanism when this ozone is we are going to carry out the mechanism when ozone is added to this alkene. So how can we carry out the mechanism? So what we are going to do is we are going to do this. We say one of the bonds here will be a potential nucleophile. So the bond which is going to be the potential nucleophile here is the bond which is here, because here we have a sigma bond and a pi bond. So pi bonds are very easy to be broken. So here they can act as, because we have excess of electrons here, so these can act as potential nucleophile, attacking what? Attacking the ozone. So they can attack the ozone on this oxygen there. So once they do that, meaning that we are going to have, so these electrons here attacks this ozone, then attacks this ozone on the oxygen. So once that happens, then this oxygen says that no, me, I'm too much of electrons. So this oxygen says that me, I'm too much of electrons, because it is already having how many electrons? It is already having 8 electrons. So once these electrons comes here, then oxygen will be under more stress. So once oxygen is under stress, then one of the bonds here must break. Alright, so one of the bonds here must break. So which one is going to break? Any of the bonds can break. So if this bond is to be broken, meaning that it is going to give the electrons back, or flashing the electrons back on the oxygen. Once that happens, this oxygen now is going to be stabilized. So once this has been stabilized, what will surely happen is that there will be another rearrangement where, remember, this oxygen here is having excess of electrons. So what can happen here is that one of the lone pair here can act as a nucleophile, attacking back the carbon which is here. So it can attack back this carbon like this, and therefore we are going to have that rearrangement. So we are going to have this attacking back the oxygen like that. So that procedure or this process can actually continue in a circular motion like that. So we are going to have that cyclo attack amongst those atoms for both the alkene and the ozone. So this is what will happen in the first place. Then from there, now what are we going to have? We are going to have this. So we are going to have, let's write the product that we are going to have after this has happened. So after this has happened, what's the product that we are going to have? So the product that we are going to have is, we have the carbon, here. Remember, we are no longer having the double bond, we are only going to have a single bond, because one of the bonds here was used to attack the oxygen. So we are only going to have a single bond here. So we are going to have a single bond, and then we have C and C, like that. Okay, so if I want, I can even do this. So I can even do this for you. I can do this. I can say, okay, I can say we have, remember we have 4 carbons, so I can bring the other 2 carbons down. All right, so after bringing them down, I want now to attach the ozone on the alkene. So that's what I'm doing. So the ozone, attaching it on the alkene, we have this bond here, which is connecting to the oxygen like that. So that is connecting to the oxygen, and then we also have this bond connecting to the other oxygen like this. Then we also have another bond here connecting to the oxygen like that, and then we have this. So this is what I have. So I've just connected this to the alkene. Remember, here we are no longer having a double bond, we only have a single bond. Here we have this bond connecting the carbon, which I've connected here, and so on and so forth. So that's what we have. But now don't forget that this has 2 electrons. So here we have 2 electrons, here also 2 electrons. So if you want, you can put them like that. So we have 2 lone pairs, here also 2 lone pairs, here also we have 2 lone pairs like that. All right, after that has happened, what we formed is what we call as unstable monoxide. So this molecule formed here is unstable monoxide. It's very, very unstable, such that if you are to leave it like that, it can cause a lot of serious damage to the environment. All right, so what we are going to do is we are going to do what we call as a cyclic rearrangement. So we are going to look at a cyclic rearrangement or cyclic attack. All right, so that addition which is going to take place here is that there will be some rearrangement where we are going to have, let's say, remember we have this oxygen here which is having these 2 lone pairs, also this oxygen which is having 2 lone pairs. So what can happen here is that the lone pairs can rearrange. They can say, okay, let me come here. So this one can say, it can come to attack this one here. So it can come to attack the carbon. So once they attack the carbon, this carbon says, no, you guys, me, I'm too much of electrons, because carbon here is already stable. So once it is already stable, this carbon, remember, it is even having 1 of the hydrogens here. So meaning that this carbon is already stable because it is already having 4 electrons. So once another bond comes here, it will be under stress and say, no, you guys, you are stressing me up. What can it do? Meaning that it should release one of the carbons, one of the bonds. Which bond can it release? It is this one here. So this bond is going to be released in such a manner that it is going to come exactly here. So this bond is going to come here to form a double bond, and then once they come here to form a double bond, this oxygen again says, no, you guys, you are killing me up because I already have 8 electrons. I'm already stable in my form. So why are you giving me again these more electrons? So this one will be under stress. What happens? Meaning that it should also release one of the bonds. Which bond is going to be released? It's this one here. So that bond is going to be released. After it has been released, what is going to happen is that it is going to give this oxygen some excess electrons, or these electrons here are going to be flashed on the oxygen there. All right, so that is the arrangement that we are going to have in the unstable monoxide. So this is unstable monoxide that we formed here. Alright, so after having that, we are going to have our product. So the product that we are going to have is now going to be like this. Remember, we've done this. There is no longer a bond here. We've cut it, and also there's no longer a bond there. So meaning that we are cutting this. We've cut it into two. So we are going to write the product, which is this side, and also what is this side, like that. So we are going to write them now down here. So let's write them and see. So I have this part, which is the oxygen. So I have the oxygen double bond. So let me write it. So we have the oxygen double bond, carbon and carbon. Whatever written, I've written this one, which is here. So it's the one that I've written. So you write like that, and then we'll also write the other one, which is on the other side, like this. So let's do it. So we are going to have the carbon. So we have the carbon, and then we have this oxygen now here, which is having a double bond. So we have the oxygen having the double bond, and the oxygen here, which is having excess of electron with a negative charge there. Okay, then down here we have the carbon, like this. Whatever I written, I've written this part here. Remember, here this oxygen brought back the electrons here to form a double bond, meaning that this is a double bond that we have here. So this is a double bond that we have, and then the whole molecule is what I've written here. So these are the two parts that we have. Now, after having these two parts, what we are going to have is we are going to have what we call as a cyclo addition. We are going to have a cyclo addition on these two molecules that we formed in our solution. So how is the cyclo addition going to happen? So the cyclo addition, before it happens, we are going to do a bit of rearrangement. So we do a bit of rearrangement where we are going to rewrite this one as in form of we are going to write it as in form of resonance. So we just turn this one upside down. All right. So what we are going to do is, allow me to write it like this. So we are going to have this carbon. Then we have the double bond and the oxygen, which is having excess of electrons, like that. And then we have the carbon, which is down here. Then from here, what we are going to do is, I'm saying that I'm rewriting this one. I'm turning this one downwards. So turning that one downwards, we are going to have the carbon, and then the oxygen comes down. So this oxygen, which is having a double bond, I'm going to write it as down. And then this other carbon is going to go up like this. So this other carbon is going to go up like that. I don't know if you've seen what I've done. So I've just turned this molecule here. I've just turned it like that. So now after turning it like that, we are going to have what we call as a cyclo addition. So how is the cyclo addition takes place? So the cyclo addition takes place in this manner. What happens is that, remember, there is this oxygen which is having excess electrons. So it is having that negative charge there. So it is having this negative charge. Let me just put it. So it is having this negative charge, meaning that it is having excess electrons. So what will happen is that this oxygen is going to act as a potential nucleophile, attacking this carbon here. Once it attacks this carbon here, this carbon will say, no, you guys, me, I'm too much of electrons because I already have 4 bonds. Remember, the chemistry of carbon should only have 4 bonds. So once another bond joins it, that means it will be under stress. So once this carbon is under stress, what will simply happen is that one of the bonds must be broken. And which bond is going to be broken? The bond that is going to be broken is this pi bond, which is here, because pi bonds are very weak and easily broken. So what will happen is that this pi bond is going to be broken, and once it is broken, it is going to also act as a nucleophile, attacking this carbon here. Once they attack that carbon, then this carbon also says that, let me use a different mark, okay, just like that. So once they attack this carbon also says that, oh, yo, you guys, me, I'm under stress because I'm already having my 4 bonds. So once you guys are coming, it means that you are destroying me. You are stressing me up. What will happen? What will happen is that these double bond here, one of the bonds is going to be broken. So one of the bonds is going to be broken. Once the bond is broken, it is going to thrash or being taken to this oxygen here. So meaning that we are going to have that cyclic addition. Okay, remember on this oxygen we had a what? A positive charge because it was surrounded by only 3 bonds. So meaning that we should have a positive charge. So as these electrons are coming here, meaning that they are stabilizing that positive charge there. Alright, so that's what we call as the cyclic addition. So we have this bond coming here, so we have this bond attacking there, and then this one also leaving like that. That's what we have. Alright, after we formed that, then now let's write what we are going to have. So what we are going to have here is we are going to have this as our product. So we are going to have this. Remember, we're just writing what we formed there after the bonds, after the cyclo addition. So we're going to have the carbon. Here now we are only going to have one oxygen. I don't know if you're able to see here, we're only going to have one bond and the oxygen. So we're going to have that. And then we have this oxygen here, this carbon here. If you're able to see it, that carbon there, that carbon there, yes. And then we are going to have this oxygen attaching itself to that carbon. So we are going to write it like this, okay, and write a carbon. Then we also have this carbon which is coming down, which is this one here. Then we add to this now. Okay, so there you have two oxygens. So we have the two oxygens, which are 1 and 2. Where are those oxygens coming from? This one and that one. So those are the oxygens that I've written on top there. Alright, so after writing them on top there, remember they are being connected with a bond there. So we are going to write a bond like that. Okay, so this is what we are going to form after these undergo a cyclic addition. So once they undergo a cyclic addition, what then is going to happen is that we are going to make sure that we remove one of the oxygens from this compound that we formed. So for us to remove one of because remember we are carrying out a process called ozonolysis. So ozonolysis, the main aim of ozonolysis is to make a cleavage. A cleavage meaning that to cut the alkene into two parts. So now for you to cut the alkene into two parts, what will happen is that we are going to bring what we call as a dimethyl sulfide. So the dimethyl sulfide is what we do bring. So we are going to bring a dimethyl sulfide. Dimethyl sulfide is given as CH3 SCH3. So this is dimethyl sulfide. So with the sulfur having two lone pairs like that. So what will happen is that the function of the dimethyl sulfide is to remove one of the oxygen from this molecule that we formed here. So what we are going to do is we are going to have this sulfur attacking one of the oxygens. So once the sulfur attacks one of the oxygens, what will simply happen is that this oxygen will be under stress because it is already having 8 electrons. So it is already stable with 8 electrons. So what will happen is that it will say, no, you guys were stressing me up. What will happen? This bond here should be broken. So once this bond is broken, we are going to have the electrons being shifted here. Once the electrons are shifted here, this other oxygen also here will say, no, you guys, I'm already full of electrons because it is also having 8 electrons already. So this oxygen also will be crying to say, no, please, I'm already stressed up. What will happen? Meaning that this bond also should be broken. So this bond is going to be broken. After it has been broken, the bond here is going to be shifted here. So the bond is going to be shifted here. Once it is shifted there, this other oxygen also will say, no, you guys, I'm already having 8 electrons, meaning that for this oxygen to be stable, we are going to also break a bond. So which bond is going to be broken? It is this bond here. So this bond is going to be broken, being given back to this oxygen, and therefore this oxygen now becomes detached from the molecule because this bond is no longer here, this bond also is no longer there, meaning that this oxygen is going to be given away to the sulfur like that. Okay, so after we have formed that, now we can have our final product. So our final product is where you have this molecule here alone, and then also this molecule alone. So we are going to write those two molecules. Alright, so let's do that. So by writing those, we have the carbon, here. Here we have a double bond and oxygen. That's the first one, then plus. The other one here, we are also going to write this one, which is here, where you have the carbon, double bond here, and also the carbon like that. So this is another product that we have. Then plus what in the solution? Plus we also have this sulfur, methyl sulfide, which has gotten the oxygen. So we are going to add it in the solution as well, which is going to be SCH3 with a double bond attached to oxygen like that. So this is what we are going to have in the solution. So this is simply what happens in the process or during the process of ozonolysis. So what we formed here are just two ketones. So these are ketones that we formed in the solution. So cleavage of alkenes is done by conducting the process called ozonolysis. Alright, thank you so much. So this is how ozonolysis takes place for alkene. Next time we are going to do ozonolysis for alkynes. See you next video. Please don't forget to follow my Facebook page and go also on YouTube. Please subscribe to my channel there. Thank you so much. See you next time.